Well, welcome back, fourth grade math teachers, to another Prep Talk video where we get you ready for your content that you're going to teach October 10th through 14th that you'll plan in your PLCs the week of October 3rd. In this video, we're also going to look briefly at data as you get information about your students from district checkpoint number 1 and how to look at that in a meaningful way. So thank you for joining us, and let's get right into it. In Mesquite ISD, when we look at DCP data, you're going to hear the terminology bang for your buck used often. This is just a mathematical ratio of frequency to time to mastery, and it works just like a normal fraction. A bigger frequency, which is the numerator, means that we're going to have a higher bang for your buck. If we have a shorter time to mastery, meaning that students will able to master that standard quicker than maybe some other ones, the lower that number is, which means it is a higher bang for your buck. If a question has a low frequency on STAR, that's going to lower the bang for your buck that TEK would represent. And if you have a higher time to mastery, which means it would take longer for a student to be able to master that standard, that is going to lower the bang for your buck rating for that particular TEK. And so frequency is pretty easy. We can just look at the frequency distribution document and easily tell how often standards are tested on STAR. So if you look at these three fourth grade standards, 4-5D has been tested 10 times in the last 5 years. That would be a really high frequency when it comes to being tested on STAR. However, the two supporting standards, 2E and 4B, have only been tested twice in the last 5 years, and so they do not have a very high frequency when it comes to the STAR test. It doesn't mean that we just throw out the supporting standards and never come back and revisit them, because sometimes those supporting standards have a low time to mastery, which means it would be worth our time to review and spiral and reteach those particular standards. Time to mastery is a little bit more difficult to understand. It obviously depends on the standard and the types of questions that are asked. But one thing that you can do is you can look at the predictability of the questions on STAR. If you notice patterns in the question and you see that it's a question that a student could reasonably learn how to do in a short amount of time, that would be a question type or standard to go after in your reteach and your spiral review after a checkpoint. So in summary, as we look at district checkpoint data, we want to identify 3 high priority indicators. The first one is frequency, how many times that particular standard has shown up historically on the STAR test. The second would be predictability. Can we reasonably determine how a question might be asked based on how it has been asked in the past? Do we notice any patterns in the question from previous years? And then finally, low level of difficulty, meaning that we can reasonably get a student to mastery on this standard in a short amount of time. And so when we look at our district checkpoint data, we want to focus more on underperforming TEKs instead of low-performing TEKs. We don't automatically review our lowest performing standard on a checkpoint because sometimes there's a reason that it's low performing. Maybe it doesn't show up on the STAR test very often, and so we didn't dedicate a ton of time to it in the scope and sequence. Our underperforming TEKs are those ones that show up a lot on the STAR test and that have a reasonable difficulty level or predictability and have a high bang for your buck rating. In that particular case, even if that standard is, say, at maybe 60% mastery as a class or as a school, we might reasonably think we want it to be at 80%. And so there's a 20% gap in where we would like to be versus where we were on the district checkpoint for that particular standard. And that will help you indicate which standards you should be spiraling back and reviewing as you continue to move through the content. If you have any questions about how we like to look at data, please don't hesitate to reach out to the Teaching and Learning Department, and we would be happy to talk more about it with you. As we take a look at the weekly overview now for the week of October 10th, the week really begins on Wednesday because of fall break on October 12th, and we are going to be finishing up our discussion of multiplication of 2-digit by 2-digit numbers. first of all, using partial products, which will connect back to the area model that we discussed last week, and also point us ahead to the standard algorithm that we will learn how to use on Thursday and Friday. And so I will hopefully demonstrate for you how to make these connections for your students in this video. We'll use this word problem to illustrate how we can connect all of the different concepts that we've talked about in our multiplication unit. We started in week 6 by having students use rounding and compatible numbers to estimate the solution to a multiplication problem. So the first thing that you'll want to have your students do is read the problem, immerse themselves into the story, and pick a problem-solving strategy to determine that this is actually a multiplication problem. And then you can have them round or use compatible numbers in order to estimate their solutions. So as we look at the numbers involved in this problem, a school is purchasing a class set of laptops for each of their 35 teachers, and each class set contains 24 laptops. I know I'm going to be multiplying 35 times 24 in order to get the answer, but if I look at 35, I can round that up to 40, and if I look at 24, I can round that down to 20 and multiply those two numbers to get an estimate of 800. At the end, we will come back to that estimate and see if our calculations match up with that estimate. From there, we moved into the idea of the area model when we multiply 2 by 2 numbers. In this particular case, we would take 35 and separate it into its tens and ones place, and then do the same thing for 24 and write it as 20 plus 4. From there, we could draw these lines across to set up our partial products using the area model. For the top left rectangle, we would have 20 multiplied by 30, which would give us 600. For the top right rectangle, that would be 20 times 5, which is 100. Then for the bottom left, we would have 4 times 30, which would equal to 120. And finally, 4 times 5, which is equal to 20. Adding up all of those partial products would give us the result of 840. Then moving into partial products, what you want students to see is that we're doing the exact same thing, just without drawing the area model. And so what we will do is start by writing these numbers vertically, 35 times 24. What we will then do is, again, very similar to what we did in the area model, where we will write these numbers as tens and ones. And so rewriting it in expanded form as 30 plus 5 for 35 and 20 plus 4 for 24. Then we will basically be doing the same thing as we did in the area model, taking our 4 here and multiplying it by both 5 and 30. And I'm doing it in that very specific order so that it will line up with what we do in the standard algorithm. And so 4 times 5 is going to start me off with 20, which I will go ahead and write over here. Then 4 times 30, which is going to be 120. Again, wanting to emphasize that when we do 4 times this 3 in the standard algorithm, it's not really a 3, it's actually a 30. And so 4 times 30 is how we end up with that second partial product. Then we move on to the 2 in the bottom number, which again really represents a 20. And so we will be multiplying 20 times 5 and then 20 times 30. And so starting off with 20 times 5, which is going to give me 100. I'm going to go ahead and write my numbers over here as well. And then finally the 20 times the 30, which will give me 600. Adding up all of those partial products will give us the full product of these two-digit numbers. And so what we notice is that we're going to end up with the same exact answer of 840 laptops. As we move into Thursday and Friday of this week, we will start to make all of the connections to the standard algorithm. And so we will have students, again, write this problem vertically, 35 times 24. Then we will go through the steps of the standard algorithm, starting by multiplying the 5 in the ones place of this number by the 4 in the ones place of the bottom number. 5 times 4 is going to give me 20, and so I write down the 2 and the 0 and move the 2, regroup it into the tens place. Then I multiply the 4 times the 3. But remember, that's not really a 3, it's really a 30, and so that's why it's going to have to go in the tens place down here. 4 times 3 is 12, and then I add to that 2 in order to give me 14. There are no more place values here, and so I'm going to have to just put that 1 in the 100s place. It's a good idea to have students cross out numbers that they're already done with. For example, this 4 and this 2 will never be used again in this problem, and so I can go ahead and scratch it out. I want to show you the connection between the standard algorithm and partial products. You'll notice that our first 2 partial products for this problem add together to give us the first step in the standard algorithm. You'll want to show students this so that they can start to make the connections between the different methods for multiplication. Then we move into the second step of this 2 by 2 problem. We'll be multiplying 35 this time by the 2 that is in the tens place. You'll want to have the conversation with your students and ask them the question, are we really multiplying by a 2? Of course, the answer to that question is no, because that 2 is in the tens place. So we're really multiplying 35 by 20. And that is why it is so important to begin the second step with writing a 0 in the ones place. And so that will adequately allow us to multiply the 5 times 2, which is going to give us 10, which will then make us put a 1 in the tens place. That again is why it was so important that we scratched out the 2 from before, because that 2 belongs to the first step of this problem. Then multiplying the 2 times the 3 that is in the tens place will give us 6, plus the 1 that was regrouped from the ones place. And so therefore we will get 7. And again, notice that 700 is the sum of the last 2 partial products from that method of multiplication. And so finishing this off by adding these 2 numbers together, what we notice is that we end up with the same exact number that we got using the area model and the partial product strategy in order to solve this problem. The last thing that we can do is look back at our estimate, which if we remember from the previous slide was 800, and our final answer was 840. And so it turned out that 800 was a pretty good estimate for the solution to this problem. Sometimes students can use estimation on star level questions in order to eliminate obviously wrong answers on those particular multiple choice questions. Before we wrap up the video, I want to give you some things to remember about these lessons on multiplication. First, when you're in planning with your PLC, consider as a team certain number talks that you could use with your students that will support the calculations that they will be performing when solving these 2 by 2 problems. This is a way to scaffold the information and the problem solving by getting the arithmetic part out of the way so that they can then move into the steps of partial products in standard algorithm. Have students estimate to find their answer first. This is a great practice for every star released question that your students do, and have them show you their estimation so that you can make sure that they are thinking correctly about how to round and use compatible numbers in order to estimate. Be sure students are using more than one strategy to demonstrate their understanding. This is a great way to have students check their work and make sure that they are getting the same answer using multiple strategies. Be sure that you're giving them opportunities to practice individually and in groups, and more importantly than that even, that they are solving real-world problems. This never shows up on STAR as multiply 32 times 16. It is always in the context of a real world problem. And so you want to give students the opportunity to engage with those and talk about how to understand that we are multiplying in order to find the answer. And finally, aggressive monitoring. This really lends itself well to aggressive monitoring laps because you can tell students what you're looking for through each step of the problem. And as you're walking around, you can be checking off students to make sure that they are getting each step of the problem correct en route to the final answer. Fourth grade teachers, thank you so much for watching this video on the content for the week of October 10th. If you have any questions, we are not going to have office hours, but you can reach out to either myself, Ryan Castle, or our fabulous 3rd through 5th grade math facilitator, Sherry Height. Our email addresses are on the screen, and so if you have any questions, please do not hesitate to reach out, and we would be more than happy to help you with whatever you need. As always, before you go, please fill out the survey using the link provided or the QR code on the left to let us know that you watched the video and to help us serve you better in future videos. Thank you guys so much, and please feel free to reach out if you have any questions on this week's content.